Okay, the second function took the radius, the g function took the radius and gave us the area of that circle. Okay, so using this kind of process here, I want you to find the area of a circle after 4.2 seconds after the pebble hits. So find the area of the circle 4.2 seconds after the pebble hits. Hopefully we did this Thursday, you did it for homework, this should be, boom, you got it. You understand what's going on. So find the area of the circle 4.2 seconds after the pebble hits. Okay, Christian, talk me through it.
Sorry, I was writing something.
Okay. Make sure you do it next time. Omar.
So basically, just first of all, ft is equal to 0.7 t.
Okay.
So just plug in 4.27 t.
So we're putting 4.2 in here.
Yeah.
Boom. Okay.
So 4.2 times 0.7 gives you the radius.
Which is?
Which is the 2.94.
And what would f of 4.2, what would that represent? F of 4.2. What would f of 4.2 represent? Yeah, Aaron.
The radius 4.2 seconds after the pebble hit the water.
Which is what? That's right. Exactly right. And what is that? Oh, stumped you there. Yeah, Fuda. Yeah, that's the 2.94, right? So that is that value, right? That's the output value when the input is 4.2. Or the radius when the time is 4.2 seconds. Okay, cool. So wants someone take over from there? What did you do? Nina.
Now you put in 2.4 into where r is, which is the radius.
Okay.
So that's the input, and you square it and then multiply it by 5.
Right.
And then you will get 27.15. What are the units?
I think these are inches.
Inches squared.
Is that what you got? 27.15? All right. Cool. So there's the idea of composition. The output of the first becomes the input of the next, and it gives us this final value of the quantity that we want. Okay? But so then, any questions? So then, at the very end of class, we kind of rushed through it. We said, okay, if f of t is 0.7 t, then, and g of r is pi r squared. And we said, this is r, right? This is radius. So we can put that in. So it's valid to put that radius into this g function. So we can do g of f of t, right? And so what would that be? G of what? What is f of t? Somebody knew. What is it?
0.7.
0.7? This? Is that it? No, it's f of t, right? F of t is not 0.7. What is f of t? Patrick?
It would be f of 4 point or f of 0.7. Not just g of
No, f of t. F of t is r. And that's what I want to put into g, because it's r. So I want to put f of t into g. So that's what I did. I put f of t in here. So now, what is f of t? Is it 0.7? Yeah. Nadine? No. What's f of t? Brian? 0.7t. 0.7t. That's what f of t is. The whole rule, right? And so now, what does g tell us to do with its input? So here's the input. What does g tell us to do with the input? This is like a set of instructions. We're going to be doing this a lot today. That's a set of instructions. What set of instructions is that telling us to do to the input? Justin, what does that tell us to do with the input? G. Does it tell us to multiply it by the output? No, here's our input. Our input is R. And so what is it telling us to do to R? Shola, what do you think?
Put in 0.7t R.
And what does it tell us to do to R?
Square.
Square it. So we're going to take the input and we're going to square it. And then, is that it? And then multiply by pi. See, that's what this function is telling us to do with the input. It's telling us to square the input and then multiply by pi. Okay, and if we simplify that, we get 0.49 pi t squared. And we can call that, say, a new function. We can call that h. And so tell the person next to you, what's the input and the output of h? What's the input of h and what's the output of h? Go. Tell the person next to you. Which quantity? So what quantity is the input of h? What quantity is the output of h? Muhammad, what do you think? Okay. And then what's the output? Area of the radius. That's two different quantities. Okay. Make sure you're paying attention, okay? Tim, what's the output?
Within the area after t seconds.
That's right. The output's the area of the circle for an input of t seconds. So it's kind of like what we just took this two-step process and we did what? We just make it into one big machine, right? We just made it into one big machine that takes this initial input time and then bypasses the middle. It just kind of eliminates the middleman and goes straight to area. Okay? And that's the idea of function composition. We just get one big machine that does it all at once. And our variation of it was 0.49 pi t squared. Okay, so put in a time of quick 4.2 seconds into this machine and tell me what you get. You're going to put 4.2 seconds as the input in. What value do you get? Use the formula that we did. Okay. And what do you get? 27.15?
Yeah.
And that's what you should have expected, right? Because you're doing the same thing, you're just eliminating this radius in the middle. You've got the function it's the streamline function. It just does it all in one step. Okay. So that's a kind of review of composition. Any questions? All right, so let's kind of advance the conversation here. So I want you to look at, here's this explanation. It's on page, if you want to read it, it's on page 102. It says, when traveling outside the United States, it's often useful to be able to convert between temperatures. So this function here that you're calling g of c, it converts degrees Celsius to degrees Fahrenheit. So that's the function of this, of G. The function of G is to convert Celsius to Fahrenheit. So which is the input? Is the input Celsius degrees or Fahrenheit degrees? If it converts Celsius to Fahrenheit. Celsius would be the input, right? Celsius would be the input. And then it will, G of C then is the output, which is Fahrenheit. So find G of 100. Just quickly. And so first of all, what does G of 100 represent? G of 100, what does that represent? Brooke, what is it? So G of 100 means 100 degrees Celsius. Is that right? It means 100 degrees Fahrenheit. You keep changing. Keep going. Talk it out. And what does the output represent? Okay, so there you got it. So this is the Fahrenheit temperature when Celsius is 100, right? The Fahrenheit, the output is the Fahrenheit when the input or the Celsius degrees is 100. Anybody get it?
190.
Should be 212.
Yeah.
Put it 87.
Okay? So when it's 100 degrees Celsius, this function G converted it to 212 degrees Fahrenheit. Okay? So what if we wanted, so here's our G function right here, this formula. There's our G function. What if we wanted C in terms of F? So we've got F in terms of C, right? That's F as a function of C, or F in terms of C. We want C in terms of F. What could we do to get C in terms of F? How could we handle that? Tell me your name again? Alex, that's what I was going to say.
You could isolate C.
Right, it's going to be the same relationship as this. We just need to get C by itself, and we got it, right? So how are we going to do that?
You would subtract 32
Subtract 32,
from both sides.
right?
And then you would multiply it by the inverse of 905.
Okay, and you would get
5 9
5/9 times?
half and 32.
Right. Okay, so we've got G of C is 9/5 C plus 32. And we'll call this new C in terms of F, we'll call that H. So the function of H, what is the function of H? What does it do? The function of H. If I'm writing this function of H as C in terms of F, then what is its function? What does it do? Yeah, Omar. Converts Fahrenheit to Celsius, okay? And it does that by taking the Celsius first, the Fahrenheit, and subtracting 32, and then multiplying that whole thing by 5/9. Okay, so this pair of functions, that pair of functions has a special relationship, okay? There's something special about those taken together. What is it? I'm not looking for a word or a definite, I'm looking for an explanation, right? So I'm asking, what is it about these two processes that makes them special taken together, looking at them together? Somebody new. How about Morgan? Any idea? So why would we pair these up and say, oh, these have a special relationship? What is it about them?
Because they're solving the opposite.
Okay. Yeah, solving for the opposite. Yeah, Nina.
Well, if you look at it in terms of ordered pairs, it would be the same pairs, just the points would be flipped around. So X would be Y and Y would be X.
Okay, so talk to me about, so say that same thing in terms of input and output.
The input-output pairs would be the same, but in each other's cases, one input would be the other output, and one output would be the other input.
The input and the output are switched, right? The quantities themselves, the input, so the input of this is Celsius, and the output is Fahrenheit. But in this one, the input is Fahrenheit, and the output is Celsius. Okay? So say more. So what would that mean as a process then?
It means that H of F is the inverse function of G of
So
C.
what is that? So yeah, we're talking about inverses, but what does that mean in terms of a process? What does that mean, inverse? So the input and output are switched. So therefore, what about the process that those functions perform? Audi. It's reversed, right? It's like a reverse, or it's like the one undoes the other. So for instance, we put 100 into G, and what did we get? We got 212 Fahrenheit, right? So what if I took that 212 Fahrenheit and put it into H? It better give me 100, right? Because what does H do? It gives Celsius temperature. You see? So this function undoes, or is the reverse process of what this one is. And therefore the input and the output are flipped. Okay, so let's, so we said that if you put 100 into G, you get 212. And if you take that 212 and you put it into H, we're going to get what? We're going to get 100 back. Why? Because the process of H reverses or undoes the process of G. So let's show that for any temperature. So suppose I want to start with G of C. I'm going to start with G of C. And since that's a Fahrenheit temperature, isn't it valid to put it into H? Right? Because that's what H takes, right? H, the input of H is Fahrenheit. So it's valid to take the output of G and put it into H. And so now, if I take a Celsius temperature and put it into G and get a Fahrenheit, and then I take that Fahrenheit and put it into H, what should I get? So what does this equal? What? Not 100. I didn't put 100 in there. I'm saying any temperatures, any Celsius. What's that? The C that we put in to start with. Whatever C we put in, put it through the G process, put it through the reverse process, should get this back. So let's show that mathematically. So what is G of C? What is G of C? It was given, right? 9/5. Okay, so now, what is this telling us to do? We have to look at the set of instructions that H is. What set of instructions does H perform on its input? And we got to do that on the new input of H. Okay, so what was H of F again? 5/9 F minus 32. Okay, so who can write what this equals, right? So here's the set of instructions for H. Sorry. The input on H, and now here's our input of H. So what does this equal? Does it make sense? Can you do it? This Jared here.
You plug in 9 over 5 times equals 32.
Uh-huh. Yep, here's the input. And so tell me.
Whole thing.
Yep.
So it'd be 5 over 9, and then parentheses, 9 over 5 times C plus 32.
Okay.
Minus 32.
Did you do it? So this is our set of instructions for H with this input, right? With this input, 9/5 C plus 32. Okay, now we can do a little bit of work here. So what can I do in the parentheses? Does that simplify it all? 32 minus 32 is 0. Can I keep going here? 5/9 times 9/5 is 1, leaving me there. So it did what we thought, right? Did exactly what we thought. We took G and we put G into H, and we mathematically showed that you get the Celsius back every time, which is exactly what we expected. So I want you to practice. I'll take attendance. I want you to do the math of G of H of F. So, and what should you get when you're finished?
G of H of F. I wasn't entirely sure here. I supposed to just wrote out the functions.
Well, what's it telling us to do? It's telling us to input H of F into G. What is H of F?
H of F is 5 over 9 multiplied by F minus 32.
So that's it. We're going to put that in for G. Okay, so now here's the step. So g is a function. It tells us something to do with the input, and here's our input. I'll underline the inputs in red. So we're going to do what g tells us to do with the input, which I underlined in red. So what would that be? Anna? Nine fifths. Multiplied by this whole thing, right? Yeah, because it's g is 9/5 times the input, and then plus after that plus 32. Is that what you did? That's what g says to do. It says take the input and multiply it by 9/5, and then after you're done doing that, add 32. And so what happens first? Simplifying. 5/9 and 9/5 becomes 1. And then we got f minus 32 plus 32, which is f, which is exactly what we were expecting, right? So first the 9/5 and the 5/9 multiply to be 1, and then f minus 32 plus 32 is f. Okay. Questions on, we're working on the idea of inverse, right? So the idea of inverse is that if you put an input through a process and then take that output and put it through the reverse process, what will happen? You're going to get what you originally started with, right? What you originally started with.
I just have one question.
Sure, please.
So in the beginning, when you reversed the formula, when you had the formula for Celsius, you changed this formula to, when you had the formula to change for Fahrenheit, how did you change the formula to make it to?
We just solved for C, right? So we had that right there. It's the same relationship, we just need C to be isolated.
So basically we just need to find C.
Just get C by itself.
Oh, I see.
Yep, that's it. Cool, other questions? All right, what's next? Okay, so just quickly, oh, right, okay, we're going to do this. All right, so now we're talking about inverse functions. And so this was our g of c function. That we started with. And so now, since it's very closely related to g, instead of giving it this new name h, we could also do this, and this is what's more common, g inverse. So this is now what we were calling h before, g inverse. Why? Because that shows us, oh hey, so right away we see, oh that's the inverse process or the reverse process of g. So this is the notation right here. It does not mean raising it to the negative 1. It's not an exponent. It's notation for the reverse process of the original function. And what we'll see often is this. X generically means input. So what is g of x? Someone tell me what g of x is. What is g of x? Diana, what's g of x? If g of c is 9/5 c plus 32, then what's g of x? No? It's a different way of writing the same function. So, Joe, what would it be? 9 over 5, x, plus 32, right? So now the input's x, not c. Do you see that? Yeah, so now the input's x, not... So x generically means an input of any function. So commonly, then you'll also see then g inverse of x. And tell me what g inverse of x is. Corey, what's g inverse of x? 5 over 9. What minus 32? X minus 32. So now, what's the meaning of x in the g function? What's the quantity x in the g function? Brian, what quantity does x represent in the g function? Degrees in Fahrenheit. Agree with that? One person yes, one person no. Con, what do you think? what is the input x? What quantity is that in the g function? What quantity is x in the g function? The input. What quantity is that? Alec, what do you think? It's not changed. It's the same g function we've been working with for the last 15 minutes. Nadine? Celsius, right? Celsius. It takes Celsius and gives Fahrenheit. It's the thing we started with. Now, what's the x in the g inverse function? Is it Celsius? Alex? It's Fahrenheit because it's the inverse, right? So x is often the placeholder for input. So when you have both, what's he doing? That's not the time. Okay, so x is a placeholder for input often. So you have to know what that quantity is. It's going to change between the function and its inverse. Okay, the function and its inverse. So here x means Celsius, here x means Fahrenheit. Okay, does that make sense? All right, cool. So I got a PowerPoint for you. Okay, so here, this notation. So notice that f inverse, that f minus 1 is the inverse function of f. It does not mean 1 over f. This is a common mistake students think. It does not mean 1 over f. It means the reverse process. Okay, so it's not to the negative 1. That's not what that notation is. Okay, so let's talk about some perspectives. We talked about this. One perspective is that the inverse is the reverse process of f. Okay, so you got input of f and output, and you got the machine f that cranks the output from the input. So f inverse then, it's like
The input would be the output.
that's right, exactly. So the output of f is the input of f inverse, and the output of f inverse is the same quantity as the input of f. Why? Because it's like turning the machine backwards, like turning backwards. That inverse function is like reversing the process. Okay, so here's some notation for the function f. In that notation, what I want you to identify is where in that notation do you see, I'm just going to ask you, we won't do this. So, where in this notation do you see the input of f? Where in this notation do you see the input of the function f? He wants x. Agree with that? That's the input of f. Okay? Where in this notation do you see the output of f? What's that? The whole thing? The whole thing. So that's the input right there of f. And the whole thing is the output of f. Okay, so therefore, where in this notation do you see the input of, we'll do it in red, the input of f inverse? So where in that notation, what in that notation represents the input of f inverse? Walter.
What in that notation is that output of that?
Right, so what about this shows the input of f inverse? A part of it, the whole thing? The whole thing, right? Yeah, the whole thing, because the whole thing is the output of f. Therefore, the whole thing is the input of f inverse. So, if we're thinking about the inverse function, then we need to see that whole expression not only as the output of f, but as the input of f inverse. Okay? What about the output of f inverse? Where can we see that in this notation? Where do we see the output of f inverse? Audie?
The input, the x,
X. So that, what I just circled, that's the, see, what's in parentheses is the input, but for the reverse function, for the inverse function, now what's in parentheses is the output. And the whole thing is the input of the inverse. So it's confusing. We got to practice this. It's really confusing. Okay, so how about this? So talk to the person next to you. All four things. Where do you see the input of f, the output of f, the input of f inverse, and the output of f inverse? Quick, talk through these. Where do you see there the input of f, output of f, input of f inverse, output of f inverse? Who is yet to go there? Jaden, where do you see the input of f inverse? Where in that is the input of f inverse? He wants just x. Agreed? Okay. What about the input of f? Where do you see the input of f here in this? Morgan. She wants the whole thing as the input of f. But the whole thing is also what, Jonathan? Besides the input of f, the whole thing is also what? So we said the whole thing is the input of f. But that whole thing is also an output. What is it output of? Nope. F inverse, right? F inverse. So the whole thing is the output of F inverse, but it's also the input of F. And so what's left? The output of F. Where in that notation do you see the output of F? Malin? Just X. Just X. Make sense? Okay, so you need to have that down to answer questions like this. This is number 4 on page 103. Page 103, number 4. So what we just practiced, you got to know well in order to make sense of this, because your table only gives you information about the functions f and g, but this is asking you many questions about the inverse process. So you have to know how the input and output of f and g are represented in these notations. Okay, so practice what we just worked on in order to solve these. Identifying the input and the output. Page 103, number 4, page 103. Yeah. Okay. All right, I'll do the first one and then I'll put you back to work. So what is represented? So we don't have a G inverse information. What we have is G. So we need to relate this to the function g. What is this related to the function g? This whole expression related to the function g is what? What about function g is this? The output, I heard. Is it the output of g? Input of g. Since this is the output of g inverse, it must also be the input of g. This is the input of g when? When the output of g is 3. See, it's reversed. Input and output is reversed. So we're going to look for 3 where? In the x column or the g column? And then we want the input. -1. Keep going. Does that help? That whole thing is an input of g because it's the output of g inverse. So that's what's unknown. So that's the input of g when its output is 3. So you look at g here. Output is 3. Corresponding input. That thing equals -1. Ask me. Catch me when we come around. You're not still not sure. Okay, let's skip right to a challenging one. Let's go to E. So how are we going to make a start on E? Anyone think they can?
Yes.
Jaden.
I think so.
Okay. So in this related to F, what is the 6 related to the function F? He thinks it's the output of F. What do you think? Yeah, that's right. It's the output of F because it's the input of F inverse. So where am I going to look? Which column? I look at F and I'm going to find 6. And so then this whole thing is what related to F? The whole thing. Input when the output is 6. So what we go to? 2. So now we have G inverse of 2. And what's the 2 related to G? The output of G. So I'm going to look where? I'm going to look here. And so this whole thing then is what related to G? When? The input when? When G of X is 2, which is 0. So you got a 0 for E. Does that make sense? Okay. How about back to Jared Smith back there? How about F? Can we do F? This part F?
Since you just have the regulars, G of 2, find the X column.
2. Input's 2.
Find the corresponding output of G, such as
-1. Good.
and then since you have the inverse of F of G, which is -1, you find -1 in the X column.
Is that so related to F? What is -1 related to the function F? Input or output?
The
Output of, so I'm going to look in X or F of X?
output
F of X, I find -1. So the whole thing is? Which is what related to F? the input of f that gives an output of f of -1. So the answer to part f is equal to 1. Questions following this? Okay. So here's another, that's reverse. The input becomes the output becomes the input. We also talked about this. F inverse undoes the process of f. So what f does, if we take that and put it into f inverse, result will be, I heard a couple people, what will the result be? I'm going to take x, put it through f, take that output, put it through f inverse. What should I get? X. That's it. Okay, so what I want you to do is, can you write function notation for this whole picture? So can you write function notation that represents this whole picture that I put up there? What is function notation? Like this. H of a plus 100. P, like P of Q of 3. These are examples of function notation. G of 8 minus G of 4. Those are examples of function notation. Can you write me function notation that represents this whole picture? Represents that whole picture. If you can, you're doing good. You understand what's going on. Anybody think they can do it? Omar, what do you think?
Should I just say it?
Yeah?
Okay, f of x is the input of the f inverse, which gives you x.
Okay, and so how would you write that? So if you're reading it from left to right, what would you write?
From right to left would be f inverse parentheses f of x close parentheses equals to x.
You already said? Well done. Well done. That's what this picture shows, right here. It says you start with x, you put it through f, you take the output of f, you put it into f inverse, and what will you get? X. Really important that you understand that. So that notation right there is a symbolic representation of that picture. Okay, but if f inverse undoes the process of f, then doesn't f undo the process of f inverse? So we could do it the other way. Wasn't that cool? So, write this. So, everyone write function notation that represents this picture. Justin, did you get it?
Yeah.
Tell me. F of f inverse of x equals x. Because what comes first? F inverse comes first, right? And then we're going to take the output of f inverse, put it into f. Right there, that's what we're seeing. Take the output of f inverse, put it into f. And if we do that, we undo the process, we get back what we started with. We get back what we started. Okay. Okay, so back in the not what I wanted. Where do I want to go here? There we go. Okay, so take a look on page 104, page 104. So the next question is, given a function, how do we find its inverse? Given a function, how do we find its inverse? I'm going to show you a way that you probably haven't seen before, but it really helps with this idea of reversing the process. So the first thing is, so we're going to do the volume of a sphere, okay? And that's f of, I'm going to call it f of x. And to get an x is the input quantity is the radius. And in order to get the radius, what do? You take the radius first and you cube it. And then you multiply by 4/3 pi. So the first thing we're going to do is we're going to write out the instructions that F requires, or F, what's the word I'm looking for? That F tells you what to do. I'll just put requires, because I can't think of the word. There's a word, but I can't think of it. Okay, so a function is a set of instructions on the input. So F is telling us to do something with the input. What's the first thing it's telling us to do with the input? Cube the input. So first thing is cube the input. And then what's the next thing F is telling us to do? Take that result and what? Okay, we can do it all at once, right? It's all one constant. So it's telling us to multiply the result by what? 4 pi thirds, or 4/3 pi, right? Isn't that what F tells us to do to the input? It tells us first to cube the input and then multiply that result by 4/3 pi. So the inverse process is just going to be to reverse this, undo this, okay? So let's write that out. So what's the reverse process? So in the reverse process, what would you do first? You take the output of this, which is our input. The output of this process is our input. And what would you do first with the input? If we're going to roll this back, we're going to reverse this. What would you do first?
I would say square root, but
Nope, we're going to roll it back. So what would we do first to reverse this process? Multiply? Divide by what? We're going to divide by 4/3 pi, and then after that, we're going to take that result and we're going to cube root the result. So now we can write what F inverse X is just by following those instructions. We're going to take the input. What do we do first? The input. Here's the input. What are we going to do first? Just follow your instructions. Divide by 4/3 pi. And then cube root the result. That's the inverse function. You see? See how cool that is? So you just write out the instructions that the original function is telling you to do to the input, and then write out what it would mean to roll that back, reverse it. And then once you got that set of instructions, then write it out mathematically. And that's your inverse function. So I want you to do that for 8e. 8e, you use all that space there on question 8. It's 2x minus 5. It's really small. F of x is 2x minus 5 all over 6. 2x minus 5 all over 6. That's 8e, and use all that space there. First, write out the instructions for F. Write out the instructions for the reverse. And then write the function. Sorry, Christian, did you have a question?
Yeah, I was wondering, like, if you multiply by 3/4, would you still end up with the same answer?
Yeah, you could do, yeah. But it would have to be 3 over 4 pi.
Yeah.
It does say if you multiplied by 3 over 4 pi, pi in the denominator.
Yeah, no, not
Perfectly fine. Yeah. How many steps do you have in the original instructions? You should have 3 this time. There's 3 things that you do this time. So therefore, when you turn it back the other way, you'll have 3 steps to undo it. Okay, Brooke, what is the first step that F tells us to do to the input? She wants to multiply by 2. What do you think? And then Patrick, what's the next thing? So multiply input by 2,
Subtract that by 5.
and you want F to
Take that result by multiply and subtract 5.
subtract 5 from the result. Good, that's right. And then Jonathan, what's the third step? Divide by? Divide that by 6. So that's what F tells us to do to the input. So therefore, what about F inverse? What's the first thing that F inverse would do in the process? Shola. Multiply the input by 6. And then what next? Muhammad, what will be next? Add 5 to the result. And then what would the last thing do to undo this whole process? Morgan? Divide by 2. So now we're just ready to write that out. F inverse x equals, so we got x. What's the first thing you do to it? Multiply by 6. Then add 5. Then there's the inverse of f. Okay, so now, granted, it doesn't work. So for complicated things like the square root of x plus e to the x, this won't work. So it only will work for elementary things, okay? But it sure helps you to learn inverses, right? It sure helps you to learn the idea of inverse. Any questions? So you have web work, some web work to help you practice that. Anybody have a question? Okay. Finally, the worksheet. Not that. Where is it? This. So this is really important too. Really getting these meanings and context now of a function and its inverse. So we've got the situation. F is the number of people expected at a local concert. Don't try to write this down. This is posted. This is that practice worksheet. But we do want to do as much of this as we can. So F is the number of people expected at a local concert if the temperature is X degrees Fahrenheit. G is the revenue in hundreds of dollars if the attendance is X number of people. So the first thing you're going to do, you're going to go through each one, and first you're going to say, is it valid? Is this expression, for each one, you say, is the expression valid, or does it not make sense? Okay? And if it is valid, then you're going to interpret it in terms of quantities, number of people, temperature, and total revenue. Okay? So do as many of these as you can in 5 minutes. These are really important problems to help you understand functions, inverses, and composition. Okay? So we'll circle around. Get through as many as you can get through, okay? Talk them out. Don't try to copy this down. It'll take too long, so just talk them out. What you might do to start, though, is identify the input and output of each of these, okay? That will be very helpful.
So for now, are we just identifying?
First, you're asking, you're doing two things. You're asking, does it make sense? If it does make sense, then what does it mean? You're not solving. You don't have any rules. What would it mean? What would the expression mean? What quantity? Hundreds of dollars. No, total revenue in hundreds of dollars. So if 85 comes out of G, that means $8,500, $8,500. You see? Okay, just think about it as studying for the test. Think about it as studying for the test. So, the last thing is that, so first of all, is it valid? And if it is valid, what does it represent? What quantity does or what does the X represent? This X.
X is the frequency variable, which is the number of people. So let's just say 100 people. That gives you the number of people. But then that doesn't give you the number of people. Well, you can't do X to X.
Okay, you should have determined part A. What about part A? Doesn't work. Doesn't work. Should have found that it doesn't work. What about B? Does it work?
Yeah.
B works, so therefore what does X mean? What X are we talking about there?
The temperature that gives you $100 revenue.
He wants the temperature that would give you $100 revenue.
Yeah.
People are nodding, they like it. That's right, because the output, this is output of G, right? 100 would have to be the output of G, which is revenue. And so it's the temperature that gives us $100 or hundreds of dollars revenue. And what makes that possible? Why can you do that? One reason why that works. What's the one? Yeah, Brooke.
Because the output from FMS is the same quantity as the input.
Awesome, right. The output of F, which is what? What is it? Number of people. The output of F, number of people, is the same as the input of G. Number of people, therefore that works. Keep going, got about 1 minute left.
Oh, yeah.
Okay, so if you want to stick around for a couple minutes, I'd be happy to talk through any of these with you, but these are posted in the exam prep area, so you should work on them. Work on them with each other, make sure you understand them. Again, don't forget, the test is tomorrow or Thursday. You're going on your own. Testing center. Study, it's challenging. Be ready. And then web work, the only homework is web work, which is due 1:15 on Thursday. Same place you went for this, PSA 21. Same place you went for the pre-test. I'll stay around if you have any questions on these.
I was just wondering about C.
C, okay.
C is the output of the the output of f of x would be the input of C, right?
Not the input of C. C is just the name of the question.
So,
C is just the name of the question.
I mean that one. So,
that's
what I meant. So that would be the f of x would be the output of f of x would be 70, which is the input of f of x, right?
The output, this 70 is the input of F inverse, so it's the output of F. So what is 70? 70 is 70 what?
70 degrees.
70 degrees. Degrees, is that the output of F?
That would be the output of F.
It's not the output
Oh,
of F.
sorry, so that would be 70 people, right?
70 people is the output of F.
Oh,
Because the constant, the temperature is X degrees.
okay, yeah, makes sense.
So what would this whole thing mean then?
So that would mean 70 degrees. So wait, 17 here represents the number of degrees Celsius. Fahrenheit.
No, it's the output of F. 70 is the output of F.
Oh,
What's
that's the
output
number
F?
of people.
Number of people.
Okay, and that represents the number of degrees.
Ooh, what happened?
That would represent the number of degrees, right? F of inverse.
Right, 'cause F inverse would be the input of F.
Okay.
It'd be the input of F, and we do an output of 70 people. So that would be the temperature to give you 70 people. So,
Got it. Thank you.
okay.